The topic is about fabrication of semiconductor devices. So in IC manufacturing, the semiconductor industry uses 1 wafers for fabrication ICs with bipolar transistor technology, and this wafers for MOS circuits. Once the orientations are done, the ingot is sliced into wafers by high-speed diamond saw. The wafer thickness is from 0.4 to 1 millimeter. After slicing, the next step is to polish the wafer surface. Finally, the wafers are cleaned and dried for use in fabrication of ICs. Wafer fabrication, category of the process that are used in fabrication of ICs are oxidation, etching, diffusion, ion implantation, photolithography, epitaxy, metallization and interconnections. So under oxidation, it consists of growing a thin film of silicon diode on the surface of a silicon wafer. Silicon dioxide has several uses. The techniques for forming oxide layer on silicon wafer is called thermal oxidation, vapor phase technique and plasma oxidation. In device, the thermal oxidation is more commonly used for IC manufacturing. So the silicon wafers are placed vertically into a quartz boat and quartz tube, and then the quartz boat is slowly passed through a furnace in the presence of oxygen operated at 1000 degrees Celsius. So this is the process of oxidation where O2 or H2 and carrier gases are sent into it. We have the resistance heaters on the sides and quartz furnace tube. Inside that we have the quartz boat and silicon wafers. After a high process of heating, it comes out through this vent. The next process is called etching. Etching is the process of selective removal of regions of a semiconductor, metal or silicon dioxide. There are two types of etching, wet etching and dry etching or plasma etching. And then diffusion happens here. In diffusion, it occurs in two steps, pre-deposition and the dry-in diffusion. Pre-deposition tends to produce a shallow and heavily doped layer near the silicon wafer. Dry-in is used to drive the impurity atoms deeper into the surface without adding any more impurities. So as per the diffusion, the depth into the substrate increases, the impurity concentration also increases. This is pre-deposition process and dry-in diffusion process. IC manufacturing, so we have the N2 liquid impurity surface sources given here and given through this quartz furnace tube. We have the similar kind of resistance heaters here. And finally, the output comes out through the vent to the end caps. IC manufacturing, after the diffusion process, these gases react with silicon, forming a layer on the surface of wafer that contains silicon, oxygen and phosphorus. At high temperature of the furnace, phosphorus easily diffuses into the silicon. In order that the dopant may be diffused deeper into the silicon, the dry-in step follows. This is done at very high temperature of about 1100 degrees Celsius. This high temperature causes the dopant atoms to move into silicon more quickly. So as per the IC manufacturing process, phosphorus dopant atoms are deposited here and we get the p-type silicon. In photolithography, we have before that we have ion implantation. This is a process of introducing the dopants into selected areas of the surface of the wafer. We are bombarding the surface with high energy of ions of the particular dopant, followed by photolithography, where geometrical pattern on the glass plate is transferred to the surface of the wafer. So integrated circuits IC manufacturing, we have the P silicon substrate SiO2 switched here, followed by positive photoresist, then mask placed above the photoresist and UV light direct at it. Then photoresist etched away under transparent regions of mask. SiO2 is etched away. The remaining photoresist is etched away. So steps taken to photolithic process. So thin layer of SiO2 on the surface is etched. Then photoresist, then UV, and then all of them are etched away. Two types of the photolithography materials. Positive PR, it allows the window to be opened wherever the UV light passes through the transparent parts of the mask. And negative PR allows the windows to be open under the opaque parts of the mask while the exposed PR remains on the surface. It's followed by epitaxy or epitaxial growth. It's a process which involves depositing a thin layer of silicon to form a uniformly doped crystalline structure on the substrate. And then metallization and interconnections, provisions of metallic interconnections for the IC and for external connections to the IC. Then testing, bonding and packaging happens here. So each chip is tested before the individual chips are cut from the wafer. Then bonding, it means a permanent attachment. Two types are there, die bonding and wire bonding. The metallurgical process by which the die is rigidly attached to its substrate or base. Wire bonding. IC manufacturing, sealing and leads, ceramic package and silicon chip. So proper packaging is done. It's the process of protecting the surface of the die from the environment and its intended applications. So through the whole mount, you have single side, dual side or full surface, and they have their classifications. Surface mount, again we have single side, dual side, quadruple side and full surface. Fabrication steps in PN junction diode. So same way we have the SiO2 etched here, photo positive photoresist, and then mask, then all of them are etched away. Fabrication steps of BJT. So same way we have the etching of the source, drain and gate separately, photoresist etching, and then the connection formation, all that is done here. Fabrication steps for MOSFET, the same process. We have the source, drain and gate etched above the SiO2 layer, and connections for all of them are etched. This is about the fabrication steps of semiconductor devices. Thank you.